Hello everyone, welcome back to physics class. In the last class, we have studied about uniform and non-uniform motion and acceleration. In today's class, I'll teach you graphical representation of motion. How to represent uniform motion, uniform accelerated motion graphically, what is the difference between two, and what things you can deduce out of graph of distance and time, velocity and time. So let's start. Uniform motion, that is an object traveling equal distance and equal interval of time. And when you have to draw a graph of uniform motion, what you do is you take distance on y-axis and time on x-axis. So if I draw graph of uniform motion between distance and time, so this is second and standard unit is meter. What I will get is a straight line. Right. Here uniform motion means speed is same throughout, or speed is constant, it is not changing. That means for any point, for each point over here, if I try to find out speed using this graph, I will get same answer. Now to find out speed using this distance time graph, what you have to do is you have to draw two perpendiculars. First thing is you choose any one point on this straight line. Okay, so let's say this I am going to choose. Now you have to draw two perpendicular lines, one on y-axis, one on x-axis. Okay, similarly you can choose any other point, let's say this one. Similarly draw two perpendicular lines. And corresponding to this points, I can write this as D1, this as D2, this point as T1 and this is T2. Okay, for these 2 points. Now to find speed is distance upon time. So here D2 minus D1, T2 minus T1. That will give you speed. So using this straight line, you can find out from distance time graph the value of speed. Standard unit is meter per second. For non-uniform motion, you have a curve. So for this curve, different region is going to have different speed. For example, let's say this graph. This is T, this is T. So now here in this graph, if you see, you have three regions. Starting from origin A to B, then B to C, and then C to D. So the three regions, if you have to find speed here, you will get three different speed. One for this straight line region, then for this straight line region, and for this straight line region. So if you have to find speed, you can take same like here, take any 2 point, draw perpendicular, and then find it out. Similarly for the region B to C straight line, you can do same. For C to D, you can do same. So here speed is not constant for all regions, whereas in here speed is constant for all regions, and you can find it out by using this method. Now let's see, if you have graph like this, D, T, a line parallel to x-axis. What is meaning of this graph? So if you try to read this graph, you can see at each and every time speed, this distance is not changing. It is same. Let's say this point is 5 meter and you have these different points. So at 1 second, 5 meter, 2 second, 5 meter, 3 second, 5 meter. That means time this distance is not changing. And when distance is same, that means object is not at all moving. Its position is fixed. That means here your speed is 0. Object is in rest position. Okay. So a line parallel to x-axis till you rest position of object given. This is distance time graph. This is important to note. Okay. Now let's move to uniformly accelerated motion. Uniformly accelerated motion or uniform accelerated motion. Now uniformly accelerated motion means the speed is changing, but it is changing equally in equal interval of time. That will give you same acceleration throughout. And if it is not, that will give you non-uniform motion. Here uniform motion means speed is same Uniform accelerated motion means speed is changing, acceleration is same, but the speed is changing equally in equal interval of time, 5, 10, 15, 20, it is increasing like this orderly. Then what you have is uniform accelerated motion. If it is not, then non-uniform accelerated motion. Okay, so there is major difference between uniform motion and uniform accelerated motion. Please keep this in mind. Now, whenever we have to draw graph for uniform accelerated motion, definition of acceleration is change in velocity with time. So what we'll do is we'll draw a graph between velocity and time instead of distance and time, like here in uniform motion. So here instead of distance and time, what I have is velocity on y-axis and time here on x-axis. Now if here I get a straight line, then this will tell me about uniform acceleration. Okay, and same for finding acceleration, same like distance time graph, choose any 2 point, draw perpendicular, and then find out acceleration. Okay, so acceleration is, let's say this is your initial velocity. Okay, or better I will draw a graph like this that will help you understand more easily. So let's say an object is starting from this point. So this is some initial velocity. If I start from here, that means initial velocity is 0. That also you can take. But for better understanding, I am telling you this. Let's say this is initial velocity of object. This is my origin 0. And then its final velocity, that means it reaches here, it is, let's say, v. Okay, so now what you do is, I'll draw a perpendicular line. So this is your t, right? So what will be acceleration? V minus u divided by this time, that is t. Even if you start from this line, from origin, you can use same method. Okay, so same like distance time graph. If there is a straight line between velocity and time graph, what you will get is acceleration. And at every point here, acceleration is same. And if it is, say, not a straight line, so if it is not a straight line, it is any type of curve. That means this is non-uniform accelerated motion. Okay, so this is graph of non-uniform accelerated motion. That means acceleration is not same, it is changing as this velocity is keep on changing. That's why acceleration is also changing. That's why it is not uniform. So hope difference between uniform motion and uniform accelerated motion is clear to you, because all equation of motion that we are going to do is based on uniform accelerated motion. Okay, and one more thing. So if I have, let's say, now can you tell me meaning of this? Please, if you know what is meaning of this here, message me. If not, then I'll tell you in next lecture during numericals, but I want you to figure it out. What is meaning of here? Okay, this is not time distance, this is velocity time. So here, straight line parallel to t, parallel to x-axis. What is meaning of that? That I want to know. So try to solve it and answer me back, message me back. So this is all about graphical representation of motion. How to find out velocity, acceleration, speed using distance time graph and velocity time graph. And this graph we will use to find out the equation of motions also. Okay. So in the next topic, I will cover 3 equations of motion. And after that, one lecture I will dedicate to numericals based on this equation of motion and acceleration, because first equation of motion, it is nothing but definition of acceleration only. Okay. Okay, so once we'll do this equation of motion, then I'll dedicate one lecture for numericals. Thank you.